Welcome to MySQL Developer Essentials series. Throughout this series, we will discuss Azure Database for MySQL Flexible Server concepts, use cases, tips and tricks for both beginner and expert level MySQL developers. In Season 2 of the series, we will cover some of the more advanced topics. In this episode, we will talk about how to build web applications and microservices in Azure with Azure Database for MySQL Flexible Server. Then we will discuss security and, more importantly, how you can ensure your application data is secure with Flexible Server. We will talk about the various aspects of high availability and disaster recovery, and in the last episode we will cover monitoring and performance optimization. MySQL is a relational database management system which supports a rich set of SQL query capabilities and offers excellent performance through storage engines optimized for transactional and non-transactional workloads. One of the most common use cases for MySQL databases is web applications that need data persistence. By leveraging Azure, developers can easily modernize their applications, expedite application development, and adapt application requirements to meet the demands of their users. Microsoft's development suite includes tools such as the various Visual Studio products, Azure DevOps, GitHub, and low-code Power Apps. Developers can deploy MySQL on Azure through virtual machines, but for most use cases, Azure Database for MySQL Flexible Server is the preferred offering that allows developers to focus on application development and deployment instead of operating system and database management, patching, and security. Now, you may be wondering, what are the most common cloud application architectures and which Azure services should you use? The most common cloud application architecture is web applications that are built using one of the most popular frameworks such as PHP, Java, Python, Docker containers, Ruby, Node.js, and more. As a developer, you can deploy these types of applications to Azure using Azure App Service. Azure App Service is a managed production environment for your application, and it automatically patches and maintains the operating system and language frameworks for you. You will be able to spend time writing great apps, and you can let Azure worry about the platform. Azure App Service is compatible with manual deployment mechanisms including zip files, FTP, and local Git repositories. It also supports automated mechanisms like GitHub Actions to build, test, and deploy your code right from GitHub. Coupled with powerful management tools such as the Kudu console, App Service is suitable for many enterprise applications. Azure App Service also lets you build applications for global scale with high availability. You will be able to scale up or out manually or automatically and host your apps anywhere in the global data center infrastructure of Azure. If you are developing web applications using content management systems such as WordPress, Joomla, or Drupal, you can deploy these environments easily to Azure App Service using application templates that are available through the Azure Marketplace. There is another application pattern that is very commonly used in modern cloud-native applications, and this is called event-driven applications. Some examples are applications that need to react to a series of critical events, or you need to build a web API for your web application. You may also need to build custom logic that responds to database changes. In these types of situations, Azure offers a serverless platform, which means that you are only built for the execution time of your code, and Azure automatically scales compute resources up and down in response to demand. An Azure Functions instance consists of individual functions that execute in response to a trigger. These functions interface with other Azure resources through bindings, although resources without default bindings such as Azure Database for MySQL can be accessed through language-specific connectors. Like Azure App Service, function apps support multiple programming languages, and you can extend support for unsupported languages through custom handles. For long-running stateful serverless architectures, such as when human intervention is necessary, Azure provides the Durable Functions extension. Azure Logic Apps provide integration services for enterprises connecting applications that reside on-premises and in the cloud. Logic Apps allow you to create and run automated workflows that integrate your apps, data, services, and systems. Some examples of typical use cases for Azure Logic apps are integrations and workflows between an email system and your application, routing and processing of customer orders between several applications and databases, moving files between storage accounts, or when you need to create an alert or tasks for items that need review. Azure Functions and Azure Logic apps give you a complete serverless application development experience, from building and debugging locally to deploying and monitoring in the cloud. One of the many benefits of Azure is built-in monitoring. You can monitor and analyze code performance with Azure Application Insights, which gives you actionable insights on performance bottlenecks and failure hotspots across all components of your application. Many developers and organizations deploy microservices architectures to offer resilient, scalable, and developer-friendly applications. Unlike traditional monolithic apps, each microservice operates independently and can be updated without redeploying the application. Each service also manages its own persistence layer, which means that service teams can perform database schema updates without affecting other services. While microservices apps offer major benefits, they require advanced tools and knowledge of distributed systems. Organizations utilize domain analysis to define optimal boundaries between services and use well-defined APIs to implement communication between the services. A single small team of developers can write and maintain a microservice, and they can make independent decisions on which technology stack, libraries, or frameworks they want to use. Since microservices communicate with each other using well-defined APIs, API management is very important. Azure API management allows organizations to manage and securely expose their APIs hosted on diverse environments from a central service. API management simplifies legacy API modernization, API exposure to multiple platforms, and the exchange of data between businesses. Applications call APIs through an API gateway that validates credentials, enforces quotas, serializes requests in different protocols, and more. Developers operate their API management instances through the management plane in Azure, and they can expose API documentation for internal and external users through the developer portal. On Azure, organizations often deploy microservices to Azure Kubernetes Service and use CI/CD or continuous integration, continuous development platforms, such as GitHub Actions. Azure Kubernetes Service provides many enterprise features, such as deployment of the application or the microservice across nodes that live in multiple Azure regions, load balancing, automatic restarts, redeployment, and more. Kubernetes apps that persist data in Azure Database for MySQL Flexible Server also get many benefits. For example, you can co-locate Flexible Server and Azure Kubernetes Service nodes in the same availability zone to minimize latency, and as a developer you will be able to manage Flexible Server instances directly from AKS using the Azure Service Operator. With Azure, you can build and host your web and mobile applications using the languages, tools, and the platform of your choice. And you can use Azure Database for MySQL Flexible Server as the managed database service for your high-performance data-driven apps. You should also know that Azure has an integrated data platform and many AI services that allow you to build intelligent and innovative solutions for any type and shape of data. You can use Azure Database for MySQL Flexible Server for your relational transactional data, and as part of the solution, use managed database services such as Cosmos DB for JSON or graph data. With Azure Cosmos DB, you can use multiple database APIs such as MongoDB, Cassandra, Gremlin, and Table APIs. For ETL and data integration pipelines, you can use Azure Data Factory. And if you need to analyze and get insights from both relational and non-relational data in your solution, you can use Azure Synapse Analytics. If your application needs a reporting interface with a dashboard, KPIs, and metrics in it, you can use Power BI. Power BI allows you to build mobile BI experiences for the users of your application. And for machine learning algorithms and when adding artificial intelligence to your app, you can use popular Azure services such as Azure Machine Learning, Azure Cognitive Services, and Azure Applied AI Services. In this video, I discussed various architectural patterns of cloud-native applications and the different options you have in Azure to host your applications with Azure Database for MySQL. Sometimes it may be hard to get started with a new application project with so many things to consider. To give you some guidance, we have some great resources in our documentation, including tutorials, best practices, and quick start guides. There is also a new practitioner page and a guide for MySQL developers who want to build and deploy applications in Azure. I hope you enjoyed this video. In the next video, I'm going to talk about security and how to secure your sensitive data in Azure using some of the features we have in Flexible Server. Thank you for watching.